backdoor data into this newly allocated memory. It will save the management frame handler function pointer. And this management frame handler is the one responsible to take care of all the management frame received to this interface, the interface of the machine we are exploiting. And then it will overwrite this management frame handler with a pointer to our backdoor code. And then we restored the stack with a frame 2 levels up, so we can exit the IOCTL nicely, and we return a list without any access point and without any errors. So the calling application, in this case the EPA's applicant, it won't get any failure here. And the management frame handler I was talking about, that is the function. It is very similar to the ICMP input function that Klaus talked about earlier, but this is the one function responsible to handle all the management traffic to this station. And what we does here is to inspect all the incoming frames, and we look for a magic number at a fixed position. And if this magic number is found, it will pass it on to the backdoor itself and process the command as it assumes is a backdoor command. If that magic number isn't found, it will pass it on to the real management handler. As I said earlier, we stored away a pointer to the original management frame handler. In this way, we are transparent to the normal operation, so we don't interfere with the normal wireless management here. So the target won't notice any difference if he has the backdoor or if he doesn't. So now the backdoor is in place, and what it does is, if it wants to send back data to the attacker it sends them back with a probe response frame. So we are only communicating in the management frame layer, and when the attacker sends commands to the backdoor itself, it sends themselves as a probe request. So our backdoor communication is with probe requests and probe responses. So in this case, we never send any data on the data level. Okay, 15. And the backdoor I've implemented here implements 3 commands. It is a ping command, upload, and an execute. And with this upload and execute command, it is possible to implement a dynamic plugin facility, which makes it possible for us to insert more backdoor code on the fly, and then later on call this. So, what I've done is to implement a file server plugin, so we have the ability to browse the target file system, and we can read arbitrary files and create and write arbitrary files as well on the target system. And we are dealing with an unreliable medium here, so it's very important that we take care of dropped frames, etc. So every command is acknowledged by the backdoor. In this way, we keep all the logic and all the resending on the target side. So this simplifies the implementation. And let's see here. And all the file system operations we do them at the VFS level. So we don't call any system calls, etc. So this is pretty stealthy, and we just does the file system operations the way that a system call would have done it. And as the payload and the exploit will be presented to you later on. I won't go into all the details because there's a lot of obstacles that you might have occur here, but it's better to have a look at the real code later on. And as a last word, I would like to say that the wireless framework in BSD is a huge work, and it deserves a lot of credit because it unifies a lot of things. But it might need some cleaning up and security auditing. And now I'm going to demonstrate this exploit that I was talking about. And I will have to fix the monitors and see if it will show anything for you. Let's see here. Oops. Okay. So, yeah. So this is the target machine. This is running FreeBSD 6.0. This is my attacker here running NetBSD with my customized kernel. And this is the access point here that we are using. And this client, this target machine, is authenticated to that access point using VPA PSK. And the traffic should be encrypted with TKIP. And oops, we should have a look at that now. So on my attacker machine now, which I switched to now, I have a sniffer installed. And unfortunately, we have pretty poor resolution on this machine, so we have to see if this is... if we can see something here, but I think we can do something useful here. Over to the target machine. First of all, we want to verify the connection to the access point here. And we open up Mozilla here, and we're going to connect to the web interface on that access point. So, this. Okay, so here we have the web page of that one. We reload it a couple of times. Oh, sorry. So, reload it some more. Here. Switch over to the attacker, and I will filter some traffic out here because it's a lot of traffic in this in the air here. So let's see here. Here we have some traffic here. Okay, so this is data sent from the client to the access point here. And we're going to have a little bit of a look here into this frame that is sent. And we see that this frame is encrypted with TKIP, so the data itself is not readable by us, the attacker. So we need to do something else here. In this case, we want to use this exploit to get hold on the target machine. And this is my exploit application. It has a couple of options here on the right side panel. It can search for access points, for example, and it will passively listen at all the beacon frames sent into there here. So we see the XXX SSID ID, and this is our network, and we search for client here. And now we are a little bit intrusive here because we are disassociating all the clients associated to that network. Because again, the management layer is unauthenticated and unencrypted, so we are free to disassociate any user. And we do that. Now we have the MAC address of the access point and the client here. So this is what we need to mount the attack here. And we we just install the backdoor here, sending the exploit. So at this point, we are switching over here to the target, and it lost connectivity to the access point. Because I said earlier, we need VPA supplicant to call this IOCTL, and it does that when it's in the searching state. And because the frames are unauthenticated and unencrypted, it is trivial for us to get the target into that state. And it is like this for maybe 10 or 20 seconds, and now again he has connectivity to the access point. And if we look on the attacker machine here, we have hopefully, or I know we have installed our backdoor, and we got a ping response here, and this is not a ping command of an ICMP ping, but our backdoor command. So we upload the file server to the target machine, and now we are browsing the file system on that machine, the target, and we might want to just have a look here on a copyright file for BSD. It is resided on the root directory on the target machine here, and we can just switch over here to the sniffer. So we will have a little bit of a look here on how this the backdoor traffic is seen in the air. Okay, so we have to filter some out because there's a lot of frames in this dump here. And let's see here. Okay, so what we see here is a probe response, and if we look at the bottom here, we see that this is the command from the attacker to the target, and he is specifying which file he wants to read from, and then the next frame, it is within a probe response, and it is we have some data here on the optional probe response field, and we can have a look here. And okay, so it won't interpret this, but this is parts of the file, of the copyright file here. So now we are browsing the target file system, and so we entered the home directory of the user here, of the only user on this machine. And I'm switching over to the target machine again. Create a folder here. Okay, so now we just create a file here with unknown content. Like this. And we switch over to the attacker here.